I should have practiced. Okay, whatever. Hello, everybody. Welcome back to another video of Tutor Bros. And this is sort of what we did a few days ago. I don't remember when. But yeah, it was for parabolas. And so today, we're going to be continuing the Conics series. And instead of doing parabolas, we're going to be doing ellipses. And you guys might be like, whoa, 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 where's circles? Usually people do it parabola, circles, ellipse, hyperbola. Well, circles has a lot of things that you probably need to learn, and just doing like analytic, like graphing sort of sense circles, it's also really hard. Like there's a lot of things to cover. I still have my scripts, so yeah, hopefully you guys find this helpful, and let's get started. So hopefully I can like do this pretty quickly, but there we go. Why is my thing on that? Whatever, I don't care. Okay, so for an ellipse, you have two types, just like a parabola, where you can have a vertical
or a horizontal. For an ellipse, actually, I'll just make it a tiny bit distinct. There you go. Okay, good. For an ellipse, you have a horizontal ellipse and a vertical ellipse.
And you guys might be like, whoa, that's just a cylinder. What's so different? I mean, not a cylinder, an oval there.
There we go, sorry. That's just an oval. Well, the cool thing is, if you have a pin, and I'm honestly too lazy to do this in real life. Those look like guys, I'm sorry.
If you have like a pin, like a thumbtack, and then you have another thumbtack, and then you cut off a piece of string. Let's say that string was blue. Okay, and like you roll it around or stuff, yeah. And then you have a pencil. Pretend that's a pencil, please. I suck at drawing. Then if you keep on
like rotating it around, like if you just like make the string taut and just keep stretching it out
as much as possible, and then just follow the path it draws for you, it'll be an ellipse. And that's the definition of an ellipse. If you have 2 points... Wow, I didn't write this in my script. Okay, I need to recall this from memory. If you have 2 points, these are called the foci. Just like in a parabola, there's a foci, but instead of 2 points, there's also a line. These are called the foci, and for any point on the ellipse, please pretend that's an ellipse. For every point on the ellipse, the sum of the distances, A and B, let's just say they're A and B. Actually, just to avoid confusion, I'll do P and Q. For any 2 points, P1, Q1, I don't care, P2, Q2, pretend that's a lowercase q, please. Actually, I'll just change it. P1, Q1, P2, Q2, then P1 plus Q1 equals P2 plus Q2. The sum of the distances is always the same. This also
satisfies it if they're on the edges. These edge points, I'll highlight them in red. I'm not even highlighting it. Why'd I say it's a highlighter? I don't know. I need water. These are called the vertex.
Actually, I'm gonna go get water really quickly. Bye.
Alright, so, yeah, I just got some water. Wait.
Yeah, on the definition. So these are called the vertex. These endpoints of the major axis. Those are the vertex. And you guys might be like, whoa, what's the major axis? Well,
if this is an ellipse, pretend that's an ellipse, please. And these are the foci. I'll highlight them in blue. Then the major axis is the axis that goes through both foci. Sort of like that. And the minor axis, sorry. Did you call the middle again? Wait, oh god. if you have like this line segment, let's just use that color. And this is the midpoint, which means those two are equal in length. Then the minor axis, I'll do it in light blue, why not, is perpendicular to this line and goes through the middle of the ellipse, the center of the ellipse. There we go, that's what it's called. So yeah, is there much to it? I think that's it for the definitions. Oh yeah, they're a Latus Rectum. I'll do it in purple, why not? It goes through both of the foci. So yeah, unlike a parabola, which only has one Latus Rectum, which is, did I not even talk about, oh yeah, here we go. This is the Latus Rectum. Well, for here, you have 2 Latus Rectum. So,
let's just go into the standard form of the equation then. So, like, the most, like, a commonly used equation, I guess, for an ellipse. Once again, this isn't going to cover slanted ones like this. Maybe later. But let's say if it's a horizontal, then it's x minus h squared over a squared plus y minus k squared over b squared, pretend that's a k, equals 1. Why 1? I don't know, because if you usually like do the factoring and all, you usually get like circle, you get something like, I'll just cover it later, it's fine. iPad's not being very cooperative today. So the center is HK. Center is H comma K. Where A is greater than B. Always. And you guys might be like, well, what's A and B? Those are half of the... This is not going well. This, for the major axis, it's half of the major axis. That is A. And for B, I'll do it in aqua. That's B. So if they were to ask you,
find the major axis, the length of the major axis, and they gave you something like x minus 1 squared over 2, that's not nice, 4 plus y minus 2 squared over 6? Is that nice? No. 9 equals 1. If they were to say, find the length of the major axis, well, a squared would equal 4, and because a is like a length, it's half the length of the major axis, a has to be positive. So a equals 2. So the length of the major axis consists of 2 a's. There's that a, and then there's that a. Pretend that's an a, please. So yeah, there's a and a. So 2a is the major axis. Sorry, I'm kneeling on the ground right now, not in my closet anymore. So yeah, 2a equals the major axis. So if they were to ask you, find the length of the major axis, well, 2a would be 4. Oh god, my voice just died. So yeah, 2a equals 4. If they were to tell you find the length of the minor axis, and then you have b squared equals 9, b equals 3, 2b equals 6, which is the minor axis.
and you know that because the minor axis is consisted of 2 b's. This length is b, this length is b. And when all is said and done, I'm wrong.
Yay. Yay.
So, if you look at a horizontal ellipse, you can sort of intuitively see that A must be greater than B. And that's sort of part of the definition. So this is all wrong, actually. A must be greater than B. Always, always, always. Because that's what ellipses are, I guess. They're not circles. If A equals B, then it's a circle. So, yeah, that A must be greater than B, or else it's not a horizontal ellipse, or it's not an ellipse at all. So, if you were to actually solve this the proper way, the reason why we got this wrong is because this isn't a horizontal ellipse. This is a vertical ellipse. And vertical ellipses look something like that, with 2 foci like that. I'm not good at graphing. So yeah. In the standard form of an equation for vertical, you would have x minus h squared over b squared plus y minus k squared over a squared equals 1. So if it's a horizontal ellipse, a is, the bigger number is under the x. If it's an ellipse, if it's a vertical ellipse, then the bigger number is on top of, below the y. So that's how you can easily tell if an ellipse is horizontal or vertical. So let's get back to this problem. If I can lasso it and move it. My iPad's not being very cooperative right now. Yes, I did it. Okay. So the
major axis Well, this is a squared because this is a vertical ellipse, because the big 9 is greater than 4 and 9 is under the y. So if a squared equals 9, a equals 3, and 2a equals 6. This is the major axis. I'm just going to say mj. And then for the minor axis, it would be b squared equals 4, b equals 2, 2b equals 4, which is the minor.
So yeah, what else do we have? You guys might be like, whoa, well then how do we find the length of the focus? Like those. Because in a parabola, all you need is p. That's all you need. It's part of the equation. But for this, it's not part of the equation at all. Well, we've got, you guys sort of should remember this. C squared equals a squared minus b squared. If a is greater than b, and c squared equals b squared minus a squared if b is greater than a. And the reason is, well, c can't be negative, can it? And it can't be imaginary. So, like in this case. So, yeah.
And you guys might be like, well, what's c? C is what you guys have probably been asking about. If you have an ellipse, those are the foci.
This is the center. Then this distance is c. So if they were to ask you to find c, you could, you guys could find the vertex, not the vertex, the center, and then you guys could respectively just add, subtract c in the respective places. So we've covered c, we've covered the foci, and the area of an ellipse, hopefully you guys can just trust me on this. The area is AB pi. This is just sort of a good thing to memorize, and yeah. And so you guys also probably might be wondering about eccentricity, which is the last thing we covered in parabolas, where we said eccentricity is c over a, which is equal to 1. This is where c over a comes in. Eccentricity equals c over a, and the eccentricity of an ellipse is less than 1 and greater than 0. And maybe when I finish hyperbolas and maybe circles, I'll tell you guys what eccentricity really is. And yeah. There's one other thing, which is the length of the Latus Rectum, but I have that on my computer and I forgot to print it out. So I'll be back in just a bit. Right, I'm back. So the Latus Rectum, I just wanted to make sure because I don't want to teach you guys the wrong things. Like last video, I made a mistake and that was kind of embarrassing when my brother caught it or somebody caught it. I don't remember. If this is a foci, any color, please. Okay, these are the Latus Rectum, like I said earlier on in the video. I think I did at least. Yeah, those are the Latus Rectum. You guys might be like, what if a question says, find the length of the Latus Rectum? Are they saying find both, like the sum of the lengths, or only one? And the answer, I'm pretty sure, is only one of them. And how you would find them, you could do it in two ways. One is really ugly, and the other one's just a formula. So the first
one is sort of I don't know how I did that. The first one is sort of if you understand ellipses very well. So that's the center. Then you could find the distance COA. And then you could find a vertical or horizontal line, find the intersections, and then do distance formula. So that's the first way. It doesn't seem very ugly, but it very much is. The second way is just a simple formula.
And I didn't write this down in my script because I'm an idiot. The length of the Latus Rectum is 2b squared over a if a is greater than b. And vice versa, I'm pretty sure. So, yeah. So, and 2a squared over b, that sounds very wrong, if b is greater than a. So, yeah, hopefully you guys found this useful. If you guys want me to do a problem of one of these, then I will do it. And please comment down if you have any questions or if any part was a bit confusing, because Conics is something that, pretty much everyone has trouble with. Yay, it's an end screen. So, yeah, hopefully this video helped you understand ellipses a bit more, and bye.